Hey, hi, this is Priyanka Singh again, and with a new coding problem, which is regarding to linked list cycle. Here we are given a head, the head of a linked list. We need to determine if the linked list has a cycle in it or not. Here there is a cycle in the linked list. If there is some node present in the list, that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. We need to return true if there is a cycle in the linked list, otherwise we will return false. So if we talk about this example, 3 is pointing to 2, 2 is pointing to 0, 0th pointer is pointing to minus 4, which is again pointing to 2. Now we will, if we'll keep on passing through this linked list, 2, 2's pointer is pointing to 0, then so this is how a loop is keep on going again and again, so it makes a never ending parsing of this linked list, hence it contains a loop, hence we are going to return true here since it has a loop. All right, and here if you see pos is 1, that means at position 1 this is again its last node is pointing to it, pointing to this particular linked list again, but this has not been passed in the code, hence we can't make use of this pos. We're just given with the head of this linked list. If we talk about this, one's pointer is pointing to 2 and 2 is again pointing to 1, hence making a loop in this in this linked list. Loop corresponds to cycle basically. So this is a single node pointing to null obviously, hence it doesn't contain any cycle or loop. We will return false in this case. Alright, so this is a follow-up question. So in this, one thing what you can do is, I mean, this is a very naive approach. What you can do is you can take a hash map and or you can take a hash set. All right, there you can what you can do is you can parse through each node given in the linked list and keep it, save it in the hash map, in the hash set, either hash map or hash set. All right, either of them will work. And uh, before inserting a new node into that hash set or hash map whatsoever, just make sure if it is already there or not. If it is, that means we have already passed through that node and this is the second time we are passing through it, hence we will return true. If all the node finishes up, if you have been through all the nodes present in the linked list, then that means there was no loop, no cycle, hence you will return false. So this is a naive approach. In this case, uh, time complexity would be law time complexity will be big O of n, where n stands for the length of the linked list, but there will be a space complexity as well, um, that will be of big O of n. All right, so there is, I mean, it is taking, there is higher complexity in this. Hence, a follow-up question would be like, can you solve it using big O of constant memory? That means making use of no extra data type, no extra memory. So in that case, what we can do is we can make use of an algorithm which is very popular among data structure, that is tortoise and hare, where hare moves faster than the tortoise and they move over that linked list. Okay, and in that case, if they come across, if they collide or come across, if they meet again in that linked list, that means there is a cycle which is existing. Okay, otherwise if both of them just pass through the entire linked list without collapsing, without meeting, at any point in time, that means there was no loop. Hence, we can just return false. Alright, so I'm going to use that. What we can do is, first I need a pointer. Okay. So T stands for tortoise. It starts with head, and here points to head as well. Both of these are pointing to head for now, but what will happen, tortoise will we will advance the pointer of tortoise by 1, whereas in case of hare we will increase it by 2. So I'm gonna pass through this list, alright, until h naught is equal to null, alright, until the linked list ends. So what I'm going to do is, I will increase the tortoise by 1 pointer and hare by 2 pointers. Alright. And in case where tortoise becomes equal to hare, that means this is the node that I'm come acrossing again. That means there is a loop, there is a cycle. Hence, I'm returning true. If the entire linked list ends without any loop, that means I'm starting with a head node and advancing its pointer one by one, and there is a time when I get null at the end. That means this linked list ends somewhere with null. Hence, I'll return false. There was a no cycle present in this linked list. Okay, so that's it. But there is one more corner case. This is something we are going to access. We are going to access h dot next dot next. That means if I want to get value, if I want to get next of this value, this must exist. Hence, I'll put a check for this as well. This should not be null. Then and only you will be able to access it. Otherwise, it will return null pointer exception. And in case of C++, segmentation error. All right. Now, let's run it. So this is a very popular question uh, asked in the interviews, and it's giving us right answer, at least in this case. Let's see for all of the cases. So it's accepted. That means it worked for all the use cases given by the lead code. So just to explain you um, a bit more how it is going to be in here. So our um, tortoise and hare are going to start from this head. All right, both of these are pointing to this initially, and then I'll advance tortoise by 1 and hare by 2. Then next, at next level, a tortoise will be pointing to 2 and hare will be pointing to 0. Then next time, tortoise will be pointing to 0 and hare will be pointing to 2, right? And in the next step, tortoise he was here at 0th value. Now next would be -4 and hare will jump from 2 to -4. There they meet. This is the meeting point for both of these. That means this is the node. uh, this is the node which is a part of that cycle which exists in this linked list. Hence, we will just return true at this point of time. Okay. All right. So if you guys have any problem, hope I was able to explain you the solution and give you some idea regarding it. So if we talk about the complexity of this, complexity would be big O of n, where n is the length of the linked list, and there is no memory space. There is no space complexity. I mean, it's a constant. We don't need any space as such except these two pointers which are constant if we talk about if we talk about in case of memory allocation. All right. So if you like this video, if this was helpful to you guys, then please do like, share and subscribe my channel, and see you in the next video.